Your car breaks down in the middle of the highway and won't start. A friendly driver pulls over nearby and gets out some jumper cables connecting your car to his. A few sparks, and your car comes back to life. And that's how life began on Earth. Sort of. There's a theory that life was jump-started on Earth like this billions of years ago. It all started with clouds in the sky. We've all been there, sitting by the window on a rainy day. You wanted to go out and have fun, but the rain pouring outside made you want to stay in bed and snuggle. Still, the lightning and thunder are keeping you awake. With nothing better to do, you think about how lightning even forms. Like I said, clouds, and many other things. You see, when a storm occurs, cold air and warm air meet. The warm air goes up to create thunderstorm clouds, which produce droplets, and the cold air below has ice crystals in it. During a storm, the droplets and crystals have a little mosh pit and move all around. All that bumping and grinding creates electrical charges in the clouds. If you ever replaced batteries on a remote, then you've seen a plus and minus sign on either end of the battery. The plus is where the positive charge is, and the minus is home to the negative one. And just like batteries, clouds have their own plus and minus. The positive charges are kept at the top, and the minus is, you guessed it, at the bottom. So when the charge at the bottom generates enough power, the cloud lets out energy. As the energy travels through the air, it seeks out positively charged objects, like a pole or a tree. And when it finds it, the energy is released and lightning strikes. These bolts of lightning can hit anything on the ground or travel from cloud to cloud. And thunder occurs because of the hot and rapidly expanding air. So, billions of years ago, the Earth wasn't quite like today. Thunderstorms were a lot more frequent than now, and life was still in its beta phase of things. These lightning bolts may have been the key to kickstart life by producing one of the most important minerals for life, phosphorus. DNA, RNA, and cell membranes wouldn't exist without it. It's essential in all stages of our life, from growth and mobility to reproduction. Everything that makes up who we are is in our DNA, those twirly things with proteins latched onto them. So what do lightning bolts and phosphorus have to do with each other? Does phosphorus flash in the sky whenever a thunderstorm happens? Not really. When lightning strikes the ground, it creates something called fulgurites, or in English, glassy minerals fused in the heat caused by the lightning. And when they appear, they take on the shape of the lightning bolt when it strikes the ground. Some new studies suggest that fulgurites could release phosphorus when dissolved in water. When doing so, phosphorus is able to form biomolecules, which help in forming life. Back then, volcanoes were also pretty big on erupting frequently. So, with ancient hot springs, you'd expect lightning to strike down nearby and produce fulgurites next to those hot sources of water. Scientists were able to estimate that during the early days of Earth, 1 to 5 billion lightning flashes were able to occur. So, in the next billion years or so, we can expect 1 quintillion lightning strikes. Yeah, that's a lot of zeros. With all those flashes and strikes, phosphorus was able to grab its chance to start life when dissolved in water. And of course, not just phosphorus, but a mix of many chemicals and minerals were needed to perfect this recipe. Another theory on how life began on Earth starts all the way in outer space, far away from our little blue planet. Flying through the vastness of space were meteorites. Life on Earth began roughly 4 billion years ago, and these meteorites were busy flying all over the place, with many of them hitting Earth in its earliest shape. Scientists claim these meteorites carried chemicals essential to creating life. Some of those important ingredients were carbon-based compounds, including sugars and amino acids. And they needed wet and dry cycles to bond on a molecular level to finalize the process. So once life was injected into Earth, we got to see the first organisms that were around 3.7 billion years ago. Keep in mind, there wasn't much oxygen floating around or in the water compared to now. But these microscopic organisms, or microbes, left their mark with a certain carbon molecule produced by living things. But life as we know it today wouldn't happen without oxygen, that invisible element that keeps everything alive. So around 2.4 billion years ago, These microbes began changing and became Earth's first photosynthesizers. They made their lunch and dinner using water and the sun rays while releasing oxygen in the process. With many of these new organisms, the rise of oxygen made the environment harsher for microbes, but it was starting to become the baseline for life's groovy track. A new party popped out for those who could dig oxygen. You see, mammals and other organisms have multiple cell types: bone cells, skin cells, muscle cells, you name it. These microbes were single-celled organisms, so with the rise of oxygen, many of these microbes began moving in with other microbes. I don't mean being roommates in a shared apartment. They actually merged with other microbes to become multi-celled organisms. Pretty clever, huh? Fast forward a couple billion years, and we have some of our first animals to ever exist. So actually, around 800 million years ago, the oxygen levels in the ocean and seas still weren't as high as they are today. But one of the earliest creatures on Earth were sponges. Scientists were able to determine this by studying DNA on rock samples dating back to when sponges first appeared. They also claim that sponges sped up the rise of oxygen levels by eating bacteria, removing them in their decomposition phase. Then, around 580 million years ago, more creatures began to appear. The oxygen levels were starting to be acceptable for life to flourish, and many other bizarre-looking creatures inhabited the ocean floor. Even the oldest kind of jellyfish were around. They looked like tiny aliens from another planet. I wouldn't want to find any of those in my drink. And around 40 million years after the end of that period, many of these strange creatures began to disappear. It was then that scientists were able to find evidence of worm-like creatures that were able to burrow in the ocean floor. This is probably one of the first signs of evolution for survival. Then, around 530 million years ago, evolution cranked it up a notch. There were many new creatures out there with new and never-before-seen body parts. Shells and spines and other body parts allowed some of these new animals to further survive and burrow their way around the ocean floor. And shortly after, a couple of million years, the first true primitive vertebrae appeared in something that looks like an eel. This was the creature with the first backbone. Over the next million years, many of these animals began to form skeleton-based and cartilage bodies. And after much splitting, amphibians appeared, and four-legged animals began to walk the Earth's surface. It's also worth noting that there were many mass extinctions that happened along the way. But in the end, life kept evolving. And with many plants and animals emerging, the landscape was changing in the process. Many natural disasters occurred along with ice ages that froze the land and seas. To add to the overall chaos, plenty of volcanic eruptions and earthquakes continued to change the look and landscape of the Earth. The first primates emerged around 4 million years ago, and ever since then, apes and monkeys began to branch out into their own category until humans eventually came into the picture. By understanding these theories, scientists are able to observe other planets with similar conditions. We could actually witness the birth of life on another planet. Of course, this would take billions of years to happen, but I wouldn't want to miss it.
When lightning flashes across the sky, it releases somewhere around 300 million volts, or the equivalent to power 25 million car batteries. Some say you're more likely to be zapped by lightning in your lifetime than to win the lottery. And statistics seem to prove this urban myth, as each year around 28 US locals do get electrically charged from the sky. The world's infrastructure can be affected by lightning too. That's because it generally seeks out the tallest structure around. But in certain conditions, it can also strike an open field. So scientists came together and invented a laser lightning rod that might help. This unique invention might make lightning strikes a bit more manageable, since it can guard a much larger area than the traditional one, and it's flexible. Classic lightning rods work like magnets for that powerful electrical charge. There are these tall metal devices placed on top of buildings. When a storm approaches, the rod provides an easy path for lightning to follow, preventing it from hitting other parts of the structure. The rod is also connected to the ground with a conductor, like a wire, helping the electrical charge to safely make its way into the earth. This process protects the building, and the humans in it, by directing the electrical energy away. We've been using lightning rods for the last 300 years, courtesy of Benjamin Franklin. But they're not damage-proof. When it comes to safeguarding vast spaces like airports, they can't manage. That's because they can only cover an area proportional to their height. Here's where this new, improved lightning rod can help. When the laser zaps the sky, it leaves behind a trail of superheated air called plasma. The same way a sculptor carves out traces in clay, the laser creates channels in the air. These channels then become the lightning's new favorite route, guiding it down to the ground. This new method was tested in the Swiss Alps back in 2021, and the results were promising. These lasers do have their own disadvantages. They aren't always available and need a heads up. That's because they have to be activated before a bolt hits. If you're a second too late, tough luck. Also, once the laser stops, the air loses its conductivity pretty quickly. This means the laser rod might not have enough power to guide the lightning safely. A potential solution might be monitoring the electric field around a certain area, predicting where lightning might strike. Yet, these new rods still need more testing and lots of funds. The European Space Agency found another way to make lasers useful: to turn moon dust into roads. It would make our future lunar exploration missions much easier if a laser beam could do the hard jobs, allowing astronauts to drive around the moon. This discovery might also help with another tricky issue: moon dust clinging to everything in sight. Roads on the moon might seem too much of a hustle for now, since we haven't been to our satellite since 1972. But when future space explorers will touch down again, they don't just plan to walk small distances. It'll be nice to have them driving around so they can explore larger areas. Problem is, that pesky moon dust is very fine, abrasive, and sticky. Back during the Apollo missions, it clogged up equipment, eroded spacesuits, and even caused a lunar rover to overheat. That's why scientists want to zap simulated moon dirt with a laser. This laser-powered project used a 12-kilowatt laser to melt simulated moon dirt into a solid, glassy surface, perfect for moon roads. The plan isn't to send a huge laser on the moon. This device they're testing here on Earth is like a stand-in for the sun, mimicking what lunar sunlight could do. The idea is to eventually concentrate sunlight using a big lens on the moon's surface. Some experiments have been done so far with different laser sizes, finding that a bigger beam made the whole process go smoother. Instead of dealing with tiny molten balls, they got a stable layer of molten moon dirt that's easier to work with. What they got was a glassy, somewhat brittle material that can handle downward forces. And even if it cracks, it's fixable. The laser beam was used to make triangle-shaped road parts that fit together like puzzle pieces, forming solid surfaces across lunar soil. If this goes as planned, we'll have moon roads made of interlocked triangles. This unique type of moon pavement could be the solution for landing pads too. Lasers can help piece together information on long-lost civilizations too. Discovering Maya cities has always been difficult for researchers exploring Mexico's Yucatan Peninsula. For years, experts believed no early civilization could have thrived in that harsh environment. But advancements like light mapping technology and laser scans are showing us this might not be true. LiDAR technology can lend a helping hand for archaeologists, especially in areas that are hard to physically reach. That's because it's like we're equipping computers with a pair of eyes. The whole thing works as a flashlight, sending out small light beams in the form of a pulsated laser. These beams bounce off objects like trees and buildings and come back to the flashlight. LiDAR measures how long it takes for the light to return, creating a map of the surroundings. When a self-driving car or robot wants to know where it is, it uses LiDAR to send out these light beams. By figuring out how long they take to come back and where they hit, the car or robot can understand what's around it, making it safer for them to move around through the fog or at nighttime without bumping into things. With this technology, a team uncovered the massive Maya city of Akomtun. LiDAR technology helped researchers to map the jungle floor, revealing hidden structures. Yet someone still needed to verify these findings on foot. The journey to Akomtun wasn't extremely challenging. The region, quite far from the nearest airport, is mostly unexplored, accessible only through old hunting and logging routes. The dense terrain made the trek challenging, taking the team up to 2 weeks to cover just 30 miles. But the effort paid off, revealing monumental structures like a large acropolis and intriguing shapes hinting at a marketplace or cultural center. LiDAR is also used in rovers we'll need to explore other planets. This will allow the robots we send up there to navigate their surroundings without direct human indications. It's also helped us better understand the best location to place solar panels, making it cheaper and faster for us to meet our energy needs. We might also be able to use lasers to predict how a volcano is gonna act. These structures are loaded with magma, the molten rock sneaking upwards from the Earth's insides. When a volcano blows its top, a chemical reaction happens, transforming magma into what we call lava. The specialists behind this new use of lasers think of magma as the computer code of volcanoes. It reveals information on how a volcano might pop up. That's because not all eruptions bring lava, and even if they do, there are different lava types, depending on how runny it is. Magma is like a mix of liquid, gas, and crystals that are shaken up inside the volcano. There are many elements at play before a volcanic eruption, so it's hard to study and understand that complex chemistry. To organize things around a bit, scientists hit the cooled magma, the rock matrix, with a laser, just like the ones you might have encountered if you've ever had eye surgery. It makes the chemical components easier to study. This latest laser eye method was used on samples from a 2021 eruption, which lasted 85 days. It covered over 4 square miles, spewing loads of lava that wrecked over 1,000 homes and displaced over 7,000 people. To prevent such events from happening again, scientists need more data. It's true, earthquakes and ground shifts help specialists predict what a volcano might do, but knowing a bit more about its chemistry can help a bit more.
Uh-oh, a strong wind is blowing. Black clouds cover the sky. Thunder is rumbling and is pouring down with rain. A storm is coming, but you don't care. You're sitting in your apartment listening to music and typing something on your computer. You hear a thunderclap. Look out the window and see a heavy downpour, a tornado, and lightning flashes. You close all the windows and go back to the computer. And then, bam! It seems that lightning has struck near your house. Your laptop and all electrical appliances in the home go off. The light goes out. You get scared. At this moment, you hear a strange hissing sound. You see how, like a phantom, a round glowing ball of electricity flies into your house through a closed window. It penetrates your room, hovers in the air, waits for something, and then flies back through the walls. The lights turn on, and everything comes back to normal. You've just seen a real natural phenomenon called ball lightning, and you're fortunate to be alive after meeting it. This is a rare phenomenon. Ball lightning occurs during a thunderstorm in the form of a floating sphere. It can change color from blue to orange and yellow. It's the approximate size of a basketball, but can also be much more significant. This lightning makes a hissing sound and a pungent smell. Phew! The first records of ball lightning were made in 1638 in England. Then, a giant glowing ball flew into the church window. Since then, there have been a lot of evidence of how ball lightning got into houses and frightened people. In the 20th and 21st centuries, scientists actively investigated this phenomenon. They found out that half of the cases with ball lightning were just hallucinations caused by magnetic fields during a thunderstorm. But they couldn't wholly refute the fact of the existence of ball lightning. They agreed that this phenomenon existed, and once they even managed to record it. The phenomenon of ball lightning was caught in China. Researchers studied the behavior of thunderstorms in 2012 using video cameras and spectrometers. They saw an unusual lightning strike, after which the ball appeared. It flew horizontally about 33 feet and disappeared. The spectrometer showed that the ball consisted of silicon, iron, and calcium. If it's real, then what is its nature? There are several theories. Perhaps the ball lightning occurs as a result of a lightning strike on the ground. Oxygen and evaporated elements from the soil create a reaction in the form of a round clot of energy. This explains why the spectrometer in 2012 recorded the same calcium in the ball lightning as in the ground. Another theory says that glass can generate these balls. Atmospheric ions accumulate on the glass surface and create an electric field. Together with a lightning strike, this field turns into ball lightning. That's why there's so much evidence that the sphere flies into the building through the window. In 2016, scientists pointed out that a lightning strike on the ground created microwave radiation that can form into a plasma bubble. This floating electric plasma takes a round shape and hovers in the air for a few seconds. Earthquakes can cause ball lightning too. During ground tremors, flashes of light appear from the depths of the crust. It's like lightning that comes not from the sky, but from the ground. Some of these lights may look like floating blue spheres. In 2014, scientists studied earthquake lights and found that some rocks emit electrical discharges during seismic wave impacts. In 2006, researchers at a university in Tel Aviv created a laboratory to study ball lightning. They used microwave radiation to recreate a lightning-like electric charge. In 2018, quantum physicists made a complex synthetic magnetic field similar to ball lightning. Physicists, chemists, meteorologists, and other scientists have conducted research and laboratory experiments many times to understand the nature of this phenomenon. But so far, no one has succeeded. Other glowing balls are less dangerous, but still mysterious. In clear weather, you can see strange glowing lights away from cities, somewhere in a swampy area. Previously, when there was no electricity, people noticed these lights. They thought someone needed help. What if some guy is stuck in the swamp and shines a kerosene lamp to get seen? People went to these lights to help, but fell into the swamp, and the light either flew away or disappeared. Some records speak of several lights at once. They move quickly and change their colors. Many believe that these were some kind of mystical creatures that lured people into traps. But over time, scientists managed to uncover the mystery of this phenomenon. Bioluminescent fungi and algae grow in swampy places. Sometimes they glow with blue light and create the illusion of glowing lights from a distance. Also, there's a lot of plant material in the swamps: leaves, grass, mud, clay, and tree branches. These substances decompose rapidly in humid conditions and release methane. As soon as methane contacts air, it ignites. The flame flies over the swamp in the form of a burning ball. Mysterious lights appear not only in swamps. People see them in deserts or mountainous areas. Sometimes it's headlights from cars. In other cases, it's the signal lights of an airplane. But in many cases, the nature of such lights remains unknown. And now, imagine a huge ball the size of a small city. It's like a dome, covers a large area, and protects it from tornadoes and storms. This phenomenon is called the Delco weather bubble and is located in Delaware County, Pennsylvania. That's how it all started. In 1996, one of the strongest snowstorms of the 20th century hit the U.S. East Coast. It was named the Blizzard of 1996. It covered almost all of Pennsylvania, but in the small town of Delaware County, Delco for short, the weather was good. The storm raged around but didn't touch the city. Since that year, the locals have believed that an abnormal weather bubble protects their houses. However, there's no scientific evidence of the existence of this bubble. After the blizzard of 1996, there were several more storms in the area, and forecasters claimed some storms would also cover Delco. But contrary to their forecasts, the weather there was excellent. Strangely, there is no meteorological evidence of this. One of the residents decided to investigate this phenomenon seriously. He followed the weather forecasts, looked at satellite photos, and saw how the black clouds diverged around the city. It rained heavily in the neighboring towns, but not Delco. This seems like convincing proof. And the question remains, should we believe the locals? There's one scientific explanation explaining the nature of this phenomenon. Storms may weaken here thanks to the sea air that accumulates in the Delco area. The street and the city's surrounding area are filled with this humid, cold air. It creates a sort of stabilization of the atmosphere, and when intense storms from the west collide with Delco's air, they lose a significant part of their strength. And it seems as if bad weather just bypasses the city. But there's another explanation, a psychological one. All the known information about the weather bubble came from the stories of residents. They see confirmation of this phenomenon and write about it on social media. Someone said that they'd seen a tornado pass by his house. Others claimed that the bubble had saved them from a downpour. People think that it didn't affect others if there was no trouble with their house. Imagine the TV says that a storm has started in your city. You look out of the window and see a clear sky, no wind and rain. It seems to you that the bubble has saved you again. Although behind you, a few hundred feet from your backyard, a tornado is raging and tearing the roofs off of buildings. But you didn't see it and wrote to the social network that Delco has saved your city again. In this sense, the weather bubble becomes more like a virtual one, thanks to the people who write about it. Hey, welcome to Earth 2050. You're living in a world after the great temperature shift of 2020. Days are as hot as they can be, and nights are just as cold. Humans have always depended on the environment, but now they're more vulnerable than ever. Fuel, money, precious metals all lost their value in a world where ice costs more than gold during the day, and you can exchange a brand new designer watch for an electric blanket at night. You don't remember the world that used to be because you were born in the new climatic era. You were lucky to find a good job right after college. The company you work for sells bottled water. When it's 100 degrees plus outside during the day, bottled water is on top of world sales. The antiperspirant business is booming too. People can easily go through 2 sticks a week. You wake up at 6:30 when it's still cold. The sun comes up in half an hour, and the shift will follow shortly after. There's a half-hour window between 7 and 7:30 when temperatures are pretty moderate, like spring in the old times. Most of the day, from 7:30 a.m. to 7:30 p.m., is like living in an oven. 7:30 to 8 p.m., it's probably like what they used to call autumn. From then on, it's 40 below. Today's a big day. Could mean your first promotion. You take a deep breath, slide your feet into your slippers, and head to the shower. On autopilot of the day-to-day routine, you first turn the sink faucet all the way off. It's an old-world habit your parents recommended to keep the pipes from freezing. Even though all of yours are up to code, wrapped in heating tape and insulated, you'd rather not risk it. You get dressed, the daily shorts, sandals, and tank top. They have high-tech thermo clothes that adjust for the day and night temperatures. But you don't have the money for those. Maybe if you get that promotion, you can invest in a good, efficient wardrobe. Funny thing is, you can always tell a person's status by looking at them. Some things never change. The thermos walk confidently with their stylish techwear. You and the rest of the baggers pack extra clothes for work and cold evenings. Got your umbrella? Doesn't help with the heat, but at least the sun doesn't beat directly down on you. Shades, deodorant, SPF, day supplies are good. Now for evening. Gloves? Check. Winter ding! You get a text message. It's your boss. You're coming in a little earlier today to set up for the presentation, right? You text her back and head to the kitchen for breakfast. Coffee's a luxury. Same goes for fruits and veggies. Unless you grow them at home, but your personal greenhouse is pretty modest. Tomatoes, corn, some melons, and lettuce. The greenhouse is still cold and heat-resistant like the standard model, but you definitely need to upgrade to a bigger one. No time, too much work. You grab an apple, a bottle of water, your bag, and rush out the door. You usually leave at 7:15. It's a 15-minute walk to the office, just enough to beat the heat. But you're out shortly after sunrise today. There are thousands of people on the street. Everyone tries to stay indoors unless it's during those 30-minute pockets of moderate weather. Even with the crowd traffic, you still get to the office just in time to set up for the big presentation. You majored in water manufacturing and distribution. When you told your boss about this idea of yours, she immediately invited the bigwigs to hear you out. It could cut the price of bottled water in half and put the company in the history books. You hurry to the locker room to change into your suit. The presentation goes great, despite your nervousness. Your boss tells you big things are coming your way, but take a vacation because you'll need plenty of rest before work begins on turning your idea into a reality. You go online to see your options. People don't vacation to the beach anymore because the climate is pretty much the same everywhere. That, and you can't fly anywhere. Air travel is a thing of the past, since planes can't take off in 100-degree weather. High heat means air is thinner, so the wings can't produce lift. At least, that's what your granddad told you. He was a pilot in the times before the shift. Skiing, ice skating, and snowboarding are now done only at indoor artificial snow resorts. Now that sounds refreshing. You finish work at 4 p.m. You think about going straight home, but you're in such a good mood, you decide to go for a stroll in the park. Gotta change back into your shorts and tank first. You walk along the empty streets. Hardly anyone just hoofs around in the heat of the day. Whew! You immediately understand why. You look at the city. Short groundscapers line the streets. Skyscrapers are no more. The huge temperature fluctuation between day and night made them unstable and wore them down. Plus, skyscrapers trap heat and make the city hotter, something nobody needs in this new age. You look at the rooftops, covered in solar panels. Everything runs on sun power. Cars, public transport, central heating and cooling. The sun may feel like your worst enemy during the day, but at least it helps keep you warm inside at night. The park looks nice from afar. Trees, bushes, green grass, and flowers. But everybody knows they aren't real. Unless plants are in a greenhouse, they're artificial. The daytime heat would scorch and dry them up. The blistering cold would freeze them overnight. You sit down on a bench and hear two old men talking about how different the world is today. The landscape changed so much. Ponds and lakes evaporated entirely within a few months. They reminisce about fishing trips, farms, and fields. Yeah, only desert animals made it through the shift. You can see coyotes, roadrunners, lizards, and scorpions if you head far enough out of the city. Camels have replaced cows and horses on every continent. 30 years of the new climatic era aren't enough for evolution to make any big changes, but people have already started to look different too. Skin is getting thicker and rougher to deal with the temperature fluctuations. Eyebrows are bushier to keep the sweat on your forehead from rolling down into the eyes. One of the old men looks at his watch. 7:30. We gotta skedaddle, Jim. It's 7:30 already? You've already wandered far from your house. You open your bag and dig for your pants, gloves, boots, and where's your winter coat? You keep digging. Panic rises in your chest. You start throwing things out of your bag, desperately hoping it's buried at the bottom. No such luck. You get a chill down your spine. Fear? Yes. But also because it's already cooling down. You throw all your stuff back in the bag and start sprinting down the street. 7:40. You're not gonna make it. At least the running is keeping you pretty warm. 7:50. There are no buses, no cars, no nothing. Everybody's already inside. 7:55. You know what's coming if you don't get home by 8. When it's minus 40 degrees and you're in your daytime clothes, it takes just 5 minutes for hypothermia to set in. You've heard the horror stories. People venturing out into the cold without the right gear on. First, the shivering, rapid heartbeat. Your body fights to keep you warm. Then the shivering stops, heart rate goes down. You start to feel lightheaded. Your body gives up. When they pass out, that's it. 7:58. You see your street up ahead. Come on, legs, go faster. 8 p.m. The cold knocks the wind out of you. You're a minute from your house. Just keep going. The air stings your lungs. Your eyelashes get covered in ice. Your nose is bright red. Is this it? This is how you go? 8:01. You burst through your front door and fall to the floor. Made it. You open your eyes, and the first thing you see is your winter coat hanging on the back of your desk chair. You can't help but burst out in laughter at your carelessness. This day that started out so perfectly, yet turned so quickly, like day and night. I really do need that vacation.
In 1996, one of the most vigorous snowstorms in history hit the east coast of the U.S. It was named Blizzard of 1996. From January 6 till January 8, a huge amount of snow fell in the country. The storm was so strong that people couldn't see anything around except a white veil. Huge snowdrifts formed. People couldn't leave their homes because snow had covered all the doors and windows. Someone spent hours shoveling snow to get into the car. And while they were doing this, new snowdrifts appeared around. This is considered one of the main winter storms of the 20th century. Schools and universities didn't work. Shops, libraries, and cafes were closed. You could look out of the window and see nothing but a white ice wall. The wind lifted snow into the air and blocked the movement of cars. People abandoned their cars to hide in the nearest shelter, which created many miles of traffic jams. During the snowfall, hurricanes formed and destroyed buildings. Chaos reigned everywhere. People were afraid to leave their homes. Strong wind and rain forced rivers to come out of their mouths, which caused massive flooding in nearby cities. Many states lost millions of dollars because of the destruction. However, at that moment, the residents of one small town didn't notice the problem. The blizzard of 1996 covered almost all of Pennsylvania, but the weather was not so bad in Delaware County, aka Delco. Neighboring cities were attacked by the storm, but not this one. Since about that time, a legend has appeared among the locals. They say their small town is protected by a mysterious weather bubble. In 2013, they called it the Delco Bubble. According to the locals, the bubble covers the entire Delaware County and protects it from all natural disasters and other hazards. Residents of a quiet, sunny town like to talk about this phenomenon, but there's no scientific evidence of its existence. It seems bad weather bypasses the district during huge storms. As soon as the hurricanes approach this place, they break up in different directions and then converge right after passing this area. All this happened according to the locals' words, without meteorological evidence. They remember several different storms in the 90s, including the blizzard of 1996. They announced that the storms would reach Delaware on TV and radio, but in fact, no forecast came true, and the residents enjoyed pleasant weather. One resident says that he often looks at forecasts and satellite photos and sees how black clouds disperse in Delco. It's peaceful and comfortable here. It seems as if time has stopped here too. However, the bubble doesn't protect against all problems. There were some floods there, after all. So, many residents don't believe in anomalous protection. There's one scientific explanation proving that storms are weakening in this place. Sea breezes go inland and settle in places like Delaware County sometimes. The streets and surroundings are filled with cold air. This creates air stabilization. Then when a storm forms and goes here from the west, it meets this stabilized air mass. Hurricanes lose a significant part of their strength, so it seems as if bad weather simply bypasses the district. Also, the Delco bubble can be explained with the help of psychology. Almost all rumors about the protective anomaly come from people. Residents write on social networks and tell each other about how the hurricane didn't touch their homes. In such cases, people often think that if trouble didn't happen to them, then it didn't happen at all. Imagine you go out on the porch of the house while the radio predicts a strong storm. Everything is calm before your eyes. A light breeze blows in your face. But behind, a few hundred feet away from your backyard, a real hurricane is raging. You didn't see it and went to write a post on the internet that the Delco bubble saved your city again. Storms are a dangerous weather phenomenon, and you should be wary of them, especially if you don't live inside a protective bubble. But let's say you missed all the news and reports about an approaching thunderstorm. It's okay. You'll know it's approaching you thanks to the clouds. One of these clouds is called cumulonimbus. These are precursors of thunderstorms, hurricanes, hail, floods, and even tornadoes. You will easily recognize them by their formidable appearance. They are thick, heavy, dark, and can sparkle because of the lightning created inside. The first reaction to such clouds is to escape or seek shelter. But wait a minute. Let's see how they form. The warm air lifts the smallest drops of water. They are so tiny that they form steam. Most often, this steam rises from the ocean. Since there are several times fewer of them on land, they rise high into the sky in an area with a very low temperature. There, the warm steam cools down, and the droplets turn into tiny particles of ice. Then, these frozen pieces are mixed with other particles that the planet is filled with: dust, ice, and sea salt. All these things stick together into a homogeneous mass and create a cloud. Millions of other extra particles stick to it, and the cloud becomes more voluminous. The mass increases, and drops begin to fall to the ground in the form of rain. Clouds are necessary for the planet. They protect us from the strong radiation of the sun's rays. You could say they filter the sun for us. When night falls, the clouds act as a blanket. They keep warm and don't allow the cold to penetrate inside. Almost all clouds are formless. The human imagination comes up with what they look like. But there are rare clouds that have a clear, striking shape. Lenticular clouds. They are stationary and have the shape of a huge round plate. These clouds often cover mountain peaks. Mammatus cloud. They often form under cumulus rain clouds. They look like hundreds of huge bags filled with water hanging over the ground. If the sky looks like gasoline is spreading all over it, you see nacreous clouds, common for areas with rather low temperatures. You can see it in places closer to the Arctic Circle. They get this color thanks to the sun. It shines on the clouds at a certain angle and creates this pattern. Morning glory clouds are like huge ropes stretching along the ground. You can observe this phenomenon in northern Australia. So let's go down from the clouds to the ground and look at the mysterious phenomenon hiding among the swamps. For centuries, people have been observing this strange thing. Some called it fool's fire. At night, somewhere far from civilization, you can see mysterious bright lights among forests and swamps. They glow with orange and blue colors. It seems like somebody has lit a torch and now is waving it to attract your attention. Perhaps someone needs your help, and they are signaling about it. In the past, people thought so too. They walked towards the lights and found themselves in the swamps. Now, they needed help, but there was no one around, and the mysterious lights just disappeared. Walking through swamps is very dangerous, so don't let these lights catch you in this trap. You should know that there's a scientific explanation for this phenomenon. Bioluminescent fungi and algae grow in swampy places and sometimes glow with a blue color. From afar, this creates the illusion of a small light. Wind and water sway algae with mushrooms, so it seems as if lights are flying. Also, there's a lot of organic material in the swamps: leaves, grass, mud, clay, tree branches. This stuff decomposes rapidly in wet conditions and releases methane. As soon as the methane comes into contact with the air, it ignites and flies over the swamp in the form of a burning ball. This phenomenon is observed all over the world in swampy areas, but the most famous flying lights are in the West Texas desert. They are called Marfa lights. Each of them is the size of a basketball and always appears in the desert. The lights flicker, merge, divide into two parts, fly away into the sky. However, there's no scientific explanation for this phenomenon. Maybe these are just lights from passing by cars. However, many people think that Marfa lights appear for the same reason as spook lights over swamps. There are large reserves of oil and natural gas with methane hidden under the desert. Sometimes, this gas comes out of the ground and gets fired after contact with oxygen.
The ear-piercing sound of sirens brings your relaxing Saturday afternoon to a screeching halt. You jump out of the chair and run to the window. The sky is covered in black clouds all the way down to the horizon. The trees are nearly bent over flat from the gale-force winds. Together with the rain, golf ball-sized hail crashes into the ground, on rooftops, on parked cars. It sounds like a stampede right over your head. Car alarms are going off everywhere. Just then, crack! Huge bolts of lightning flash across the black sky. Then the monstrous grumble of thunder. Your heart jumps in your throat. As you peer through the window at the sudden chaos outside, you're filled with a primal fear of the power of nature. You snap back to reality. The sirens! Gotta get to the basement! You start to turn away from the window, and that's when you see it. A massive tornado ripping along the city street. It's throwing entire motorcycles, refrigerators, and even trees like baseballs. The roof of that building starts peeling off like a Band-Aid. The twister even lifts cars and pieces of asphalt as if they're made of feathers. It seems this tornado will flatten your city within an hour tops. You finally snap out of your hypnosis and run to the basement. The sound of the city being ripped apart terrifies you as you hunker down below as low as you can. But after about 20 minutes, everything is suddenly silent. You head out to see the clouds have disappeared, and the sun's rays illuminate the street. Luckily, your house was spared, but your modern city now looks more like ancient ruins. Stop. Tornadoes never come into cities, right? Yeah, they do. This monster doesn't care where it goes and what it eats along the way. While we're at it, you can forget about the myth that tornadoes will magically stop when they meet rivers, lakes, or mountains. They just keep on going. But about that no twisters in the city thing, about 1,000 tornadoes hit the US each year. That's 75% of all the tornadoes in the world. Most of these monsters occur in a strip, okay, more like a long blob, running up and down through the middle of the country. It's an area aptly dubbed Tornado Alley, a perfect spot for these things to form. You get cold, dry air coming down from Canada, meeting warm, humid air traveling north from the Gulf of Mexico. Warm air is less dense than cold air, so it rises and creates a strong updraft. Water droplets surround it to create the funnel cloud. There you go, recipe for a tornado. Now, if you closed your eyes, spun around, and put your finger on a map of the US, the chances of your finger landing on a major city are pretty slim. If you gathered all the cities in the whole country into one area, it would only be 3% of the US's entire land. Just like your finger, the likelihood of a tornado striking in the city is much smaller than landing in a rural area. When it comes down to it, tornadoes can touch down in big cities. They just hardly ever do, thanks to sheer chance. Another surprising myth. You always see a tornado coming because, funnel cloud right ahead. Not true. The approaching funnel can be completely camouflaged in a wall of rain. You might finally see it when it's right on top of you. In this case, you'd better trust your hearing. First, tornado warning sirens go off if you're in a place that has them. Second, listen for a loud rumble that sounds like a train coming. That's a sure sign this beast is somewhere nearby. Many people immediately start heading for shelter when they see green clouds in the sky, because we all believe it's the #1 sign of a tornado coming. Don't buy it. Yes, a green sky is a sign of a severe thunderstorm that's powerful enough to produce tornadoes, but it's not a guarantee like many people see it. While we're at it, you know how movies show the ground ripping apart during earthquakes? The gaping hole that swallows cars, houses, entire cities? Not a shred of truth to this. A crack may appear in the ground with major earthquakes, but it rarely exceeds a couple feet wide. One of the most overspread myths out there is that lightning will never strike the same place twice. Tell that to the Empire State Building. It gets hit by bolts of lightning at least 25 times a year. Pretty sure nobody's picking the building up and moving it to different locations. Yes, lightning likes really tall things, and it's not shy to keep coming back. As for that old warning about your cell phone or jewelry attracting lightning, busted. There hasn't been any scientific support for the idea that personal objects with metal in them attract lightning. You still shouldn't be out and about during a storm though, cell phone in hand or not. Now, if you're looking for a tsunami and only focused on giant walls of water, you might never see one, even if it's right in front of you. Tsunamis aren't always massive tidal waves crashing into the shore. More often than not, they look like the tide is rising extremely rapidly, receding and rising again until it overspills into the city. Not that tsunamis never form walls of water, it's just not as common. Picture Earth. Are you imagining a perfect ball? Well, to resemble the truth more, squash the poles down a little. There, now you have a realistic Earth. Scientists call the Earth an irregular sphere, or ellipsoid in fancy terms. The planet rotates on its axis, causing the equator to bulge out a bit, just like what happens when you spin fast on a merry-go-round. You feel pulled out and away from the center. What's the highest point on Earth? Everest, of course. But if we go from the point furthest away from the center of the Earth, the crown goes to Mount Chimborazo in the Andes. Its peak is actually 6,800 feet closer to space than the summit of Everest. That's because Chimborazo sits near the equator, where the planet's bulge is greatest. The blue whale weighs as much as 30 elephants, makes sounds louder than a jet, and eats 4 tons of food every day. It's the largest living creature this planet has ever seen. Only, not technically. Head to the Malheur National Forest in Oregon, home to a creature that weighs as much as 20 blue whales. The honey mushroom is a humongous fungus colony united into a common system. The giant covers an area of 1,500 football fields, and it's thousands of years old. Ask anyone to draw the sun, and they'll draw a happy yellow circle. But if you look at our star from the moon or the International Space Station, you'll see that it's actually white. From Earth, the sun looks yellow or red thanks to the atmosphere acting like a filter. Most people think time is constant and moves at the same speed no matter where you are. But the speed of time depends on how close the watch is to Earth. The weaker the gravity, the faster time passes. So the person living in the apartment above you is aging faster than you. Now, it's only 90 billionths of a second faster per 1 foot higher, so don't expect to notice a difference if you decide to move to the first floor. The ground under your feet feels pretty solid and whole, but in reality, the Earth's crust is all broken up into plates surfing on oceans of liquid rock called magma. You don't feel it, but the ground under you is moving a little over ½ an inch per year. That's about the same rate your toenails grow. Largest desert in the world? Easy. The Sahara. Nope. It's Antarctica, which is almost 2 times bigger than the Sahara. A desert isn't just a scorching sandy place where it doesn't rain. It's a place with very little precipitation, so that includes snow too. In some parts of Antarctica, it hasn't rained or snowed for millions of years. In other parts, snow does fall, though rarely. Point is, there's a myth that it doesn't snow in extreme cold. Antarctica is the coldest place on Earth, and it snows there. There is some truth to this old saying. Cold is drier. It doesn't retain moisture as well. You need moisture to produce raindrops and snowflakes. That's why there are fewer chances for snowfall when temperatures drop so low.
Urbania. Sounds like a made-up city from a fairy tale, but it's not. It's real and located in central Italy. The town's name isn't the only strange thing about it. Every year, the local newspaper and television publish a strange weather forecast. It's based on onion wedges. Yes, you've heard it correctly. Italians from this region eagerly look forward to a forecast based on a vegetable. The tradition dates back to the Middle Ages. It's kept alive by the local school teacher. Every January 24th, she cuts a yellow onion into quarters. Then, she divides them into wedges, 12 of them for each month of the year. They lie neatly on her kitchen cutting board, facing east. The following morning, the onion is ready for interpretation. Because she sprinkled them with salt, the wedges change their texture. The woman uses these clues to forecast the weather for that year. She's been doing this for 3 decades, and before her, her father did it. Before him, her grandfather. You get the gist. Onion reading has become a family tradition. Historical records show that this practice has been going on in Urbania for centuries. Back in the day, farmers used this method of forecasting the weather to help agriculture. It was important to know exactly when to plant seeds and when to harvest crops. The method must have been accurate because up until the beginning of the 20th century, locals still trusted onions more than the official weather forecast. This isn't surprising. The first weather forecast based on scientific data was published in a British newspaper in 1861. Before this time, people did all sorts of things to predict the weather. The methods they used might seem pretty funny to us today. Take the woolly bear caterpillar as an example. This species lives in the United States and southern Canada. The legend goes that you can determine how harsh the next winter will be just by looking at the animal's color pattern. If the color brown is dominant, then the winter will be mild. That's an odd way to predict the weather, but believe it or not, it does have some grounding in science. You know who entomologists are? Yes, those are scientists who study bugs. Their research showed that the caterpillar's color is connected with how much food it has had. But there's a twist. The color reveals the harshness of the winter of the previous year, telling the future is not the woolly bear caterpillar's forte. People think ladybugs bring luck, but they're more than good luck charms. Have you ever heard of the saying, "When ladybugs swarm, expect a day that's warm"? This is actually true. When the weather is warm outside, these lovable insects leave their hiding. But as the temperature drops before a rain shower, they fly in search of cover. Frogs can also predict rain. Right before the first droplet, these amphibians croak louder. They actually do this because they're about to mate. Frogs lay eggs in bodies of fresh water. If rain is coming, then water levels in ponds will rise. This increases the animal's chances of finding a partner to produce tadpoles. Have your parents told you to stay away from hornets' nests? They were right, but the nests of bees, wasps, and hornets make for excellent weather stations. When they start building nests higher than usual, expect a colder winter with a lot of snow. You see, hornets cannot survive temperatures lower than 50 degrees Fahrenheit. That's why they want to stay clear of the cold as much as possible. Another animal that bulks up for winter is the squirrel. Take notice of these cute rodents the next time you go hiking in the late fall. If they seem chubbier than usual, then the winter is gonna be cold. And remember Scrat from Ice Age? The hyperactive squirrel that was constantly chasing after an acorn? When you see a squirrel acting like Scrat, then that's a sure sign of a long winter approaching. The rodents want to stock up before Mother Nature closes the shop. Have you noticed more cobwebs in your house recently? That's just spiders sensing bad weather approaching. Also, if spiderwebs are larger than usual, then they're trying to catch more prey. That's their way of preparing for a long winter. Livestock prepares for this period by growing thicker fur. If you live in the countryside and notice that sheep are woollier than usual, then it's time to invest in a warm winter jacket. Are there mole hillocks in your backyard? Apart from tripping on them, you can use them as tiny weather stations. The deeper they are, the harsher the winter. Let all those animals rest a bit. Looking at the sky can also tell you the weather. Duh! There's a popular theory that every foggy day in August equals a day of snowfall in winter. Pretty exact math for something that's just a belief. Then there's the moon. Science already knows that it has power over ocean tides. After all, the saying, "Clear moon, frost soon," has been around for a while. When the moon is shining bright in a cloudless sky, it's gonna be chilly the next morning. Looking at clouds also gives hints about the weather. White clouds high in the sky indicate a clear and sunny day. When their color changes to black and they're set lower in the sky, expect rain. The cloud's shape is also revealing. If they're ragged when you look at them from below, open your umbrella. It's gonna rain soon. Remember the onions from the beginning? They're not the only plants that can forecast the weather. In the Ozark Mountains, there is a folklore belief that involves persimmons. When you cut in half the seed of this sweet fruit, look for the shape inside. When it resembles a spoon, expect snow that winter. But if you see a fork, then the cold season will be mild. A knife shape and the weather will be windy and icy. This strange prediction based on cutlery has some logic behind it. American persimmons ripen in September and October. It shouldn't be surprising that people use this fruit to inquire about the winter ahead. The United States is the world's second largest producer of apples. That makes it easy to test another theory. If apple trees produce more fruit than usual, then the upcoming winter will be harsh. There are two explanations why this might be true. The first is that apple trees produce more food for the animals. The second is that they want to maximize the number of seeds, just in case the plants don't get through the cold spell. Walnut trees use a similar tactic. People figured out that walnuts have a thicker outside shell in preparation for a winter colder than usual. The same goes for hickory trees and oaks. Pine cones are more than a table decoration. The phrase, "open pine, the weather's fine," says it all. Pine cones open their scales during warm and dry weather. They want to spread their seeds as far as possible. But when the weather takes a turn for the worst, they close them. Cold or damp air won't disperse pine cone seeds very far. Today, no one goes into the forest to see how plump squirrels are, nor do they take out a ruler to measure pine cones. All the info about the weather we need is inside our smartphones and on the internet. In the 1950s, computers took over weather forecasting, and they've been doing it ever since. But inaccurate weather predictions still happen. Long-term weather forecasts are especially challenging. That's because there are so many factors at play. Wind, humidity, temperature, air pressure, and clouds are just the tip of the meteorological iceberg. Although it's just a tradition, Italian onion reading might not be so ridiculous after all. At least the nice lady uses the onions to make soup after everything is said and done.
So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the fifth largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that, despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So, here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet, chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, this next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet. TRES-2b, or not to be, is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES-2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri e is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side. And between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. That's a getaway spot. HD 189377b, well, I'm not going to say that again, is the only exoplanet in the orbit of its star. And at first glance, it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Better duck. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler-70, hey, I can say that one, is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. So pal, what's eating you? My mother. WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. Hey, you asked. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven. And yet, it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very, very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. I thought I thaw that thumbworth. Still, if it has a rocky core, it might generate some heat, so there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1,800 degrees, perpetually blown over with winds reaching 600 miles per hour. And that's winter. Well, actually, I don't know that. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. That'll test your mettle. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Vacation? Nah, let's keep looking. Karat Exo 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Karat 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Karat 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core. So this year, before September, a star in the constellation of Corona Borealis will explode, and in the Northern Hemisphere, we'll be able to see it with the unaided eye. The star is T Corona Borealis, a white dwarf star 3,000 light-years away from our solar system. It will turn into a nova, which we'll discuss a bit later, in spring or summer. Even though this occurrence is predictable, happening every 80 years, it's still a once-in-a-lifetime event, if you're human. T Corona Borealis is not your regular star. It's actually a binary, 2 stars orbiting each other. This pair, though, is incredibly special. Occasionally, the stars increase their brightness to such an extent that they become visible on Earth. The white dwarf star is the more massive one of the two. But the most shocking thing about it is that it might pack the same mass as the Sun into a volume only as large as Earth. The companion star, an aging red giant, has already expanded so much that it's dumping its material onto the white dwarf. So it's time for another explosion for these two. It's going to take the star's brightness from magnitude 11 to magnitude 2. You see, in astronomy, magnitude is used to measure the brightness of a star or another celestial object. The brighter it is, the lower the number assigned as a magnitude is. Just like golf, low scores, you know. In our case, it means that we'll be able to see the star with the unaided eye, even in light-polluted skies. Now, we can only see the binary with binoculars in a completely dark sky. After the outburst, T Corona Borealis will remain the brightest star in the constellation of Corona Borealis for a few days before gradually dimming. Now, this event shouldn't be confused with a supernova. In a supernova, a star's core collapses, which leads to its complete destruction. It can only happen to a star 8 times the mass of the Sun. Instead of disappearing in a blinding flash of light forever, T Corona Borealis will experience a nova, an explosion on its surface, flinging matter into space but not ruining the star itself. Such recurrent novas happen at regular intervals. T Corona Borealis was known to astronomers from the past as the Blaze Star. Last time it exploded in 1866 and 1946. Astronomers from NASA believe it's going to do it again before September this year. The constellation of Corona Borealis, also known as the Northern Crown, is one of the most beautiful out there. It's a curved semicircle of 7 stars, which is easy to find in April. You should go outside 2 hours after dark and look to the east-northeast. Once you find the Big Dipper, use the curve of its handle to go to Arcturus, finding the bright star in the Buddhist constellation due east. If you go diagonally down to the east-northeast horizon, you'll spot Corona Borealis. Now, if you want to observe the brightening of T Corona Borealis, it might be better if you get acquainted with the region and the stars of the constellation it's in. Once the event begins, you'll be able to compare its brightness against the other stars and observe the thing without using any fancy cameras. Now, a nova is a short-lived sudden explosion involving a compact star as large as Earth or a bit bigger. The outburst comes from a white dwarf circling remarkably close to a regular star, so close that a stream of gas flows between them. This gas starts piling up until it creates a layer on the white dwarf's surface, and then it reaches a point where it detonates in a runaway thermonuclear explosion. According to astronomers, around 50 nova happen every year in our galaxy, but not all of them are noticed. NASA's Fermi Gamma Ray Space Telescope has observed several nova that occurred not far on the scale of the universe. They found out that each blast produces gamma rays. Those are the most energetic forms of light. Researchers also think that these gamma rays result from collisions among numerous shock waves, racing from the explosion site in a quickly expanding shell of debris. Now, after we've talked about novae, it's time to discuss something much more dramatic: supernovae. It's the largest explosion humans have ever seen. Each blast is a super powerful burst of a star. One kind of supernova is caused by the last hurrah of an extinguishing massive star. It happens to stars at least 5 times the mass of our Sun. Once they near the end of their lives, they go out with a ginormous bang. Huge stars burn incredible amounts of nuclear fuel at their core, producing tons of energy. It makes their centers immensely hot. Heat generates pressure, and this pressure keeps such stars from collapsing. But any star is in balance between 2 opposite forces. Its gravity attempts to squeeze the star into a teeny tiny ball, and the nuclear fuel burning at the core of the star produces powerful outward pressure. Now, when a giant star is running out of fuel, it starts cooling off. Its pressure drops and gravity wins. The star collapses. An enormous object that is millions of times the mass of Earth collapses within 15 seconds. No wonder this brisk process produces enormous shock waves. It makes the outer layers of the star explode. Eventually, an incredibly dense core is all that is left behind, besides a growing cloud of hot gas called a nebula. A black hole, the densest object in the universe, is the result of a supernova of a star around 10 times as massive as our Sun. Also, there's another type of supernova. It usually happens in systems where two stars orbit each other, and at least one of these stars is a white dwarf the size of our planet. If such a star collides with another, or pulls too much matter from its neighbor, it can explode into a supernova. Also, supernovae are often so bright they can outshine the combined light of entire galaxies for several days or even months. Supernovae aren't common. Astronomers think just a few of them occur within the century in galaxies like our home Milky Way. But since the universe contains an enormous number of galaxies, we can observe a few hundred supernovae every year outside our galaxy. Unfortunately, space dust blocks our view of most supernovae happening within the Milky Way. Betelgeuse, a late-stage red giant, exploded in 2019, but it wasn't the event we expected to see. This star is found in the constellation of Orion and is huge, so big that if we moved it to the center of our solar system, its outer edge would go way beyond the orbit of Jupiter. When Betelgeuse eventually nears its end, it will explode in a stunningly bright supernova visible on Earth even during the day. This explosion could happen as soon as tomorrow or as far-flung as hundreds of thousands of years from now, so don't hold your breath. But then, what was it in 2019? Astronomers noticed that the star was dimming. They decided it was the initial stages of the grand show. But instead, Betelgeuse went back to normal over the course of the next few months. Further analysis revealed that the star hadn't dimmed. It just looked like that because we had been observing it through a cloud of stellar debris. At the same time, the amount of light in the photosphere of Betelgeuse ramped up. It was like a massive explosion of material from the surface of the star. Events like this occur on the Sun all the time, especially when our star's activity is high. Bits of the Sun's surface get tangled up and cast off. That's what we call coronal mass ejections. They don't harm our planet, but they can mess with satellites and electrical equipment. Now, getting back to Betelgeuse, we've never seen such a huge mass ejection on the surface of a star before. It's a new phenomenon which we can observe directly and even see surface details with the help of the Hubble telescope. Astronomers say we're watching stellar evolution as it happens for the first time.